Okay, so I'm going to go over 4 more examples that illustrate how to write functions, how to modify matrices, something that might be useful. And remember, it hinges on this idea of 2 sides of this equal sign. So where do we want to store something, and what do we want to store there? Asking ourselves, are we storing all of a variable, part of a variable? What do we want to store there? All of a variable, part of a variable? Which part? Which rows? Which columns? So this first example says write a function that flips a matrix top to bottom. So let's say we have a matrix. Here I've created one full of random integers between 1 and 5 with 6 rows, 3 columns. So I want to create a new matrix. So I'm going to go over here to my new matrix. It helps to have scratch paper on the side. I like to plan things out on paper first. It just helps. Where I want to flip this top to bottom. So what do I want to put in row 1? I want to put M, row end, the last row, and all the columns. So my last row, and here's all my columns. So essentially I want to put this in my first row. And then I want M and -1. All the columns. So my second last row. And then I keep going. M and -2, all the columns, all the way down to M of 1. I want to put my first row in my last column. So that's how I want to construct this matrix. So I can't necessarily do that one piece at a time because it really depends on how many rows M has. But we'll say M flipped. It's going to be a new matrix, M end. There we go, stacked on top of M and -1. Stacked on top of M and -2. And you'll notice that eventually we get to this point where we can go ahead and look at this pattern where it starts at end, and then n -1, and then n -2, and then n -3, all the way until we get to 1. So I can replace that with M flipped, where I start at M end, and then I go all the way to -1, so decrement by 1, all the way to the first row, all the columns. So this becomes my comment, and here we go. So if I do M flipped, there we go. We can see my last row becomes my first row. My second to last row becomes my second row. My third to last row becomes my third row. So I can see I'm flipping it. So where do I want to store it? In a new matrix. What do I want to store there? I want to store my rows of M, starting with the last one, decrementing by 1, all the way to the first one, all the columns. So we've got this one line that flips an entire matrix. Okay, if we want to put that in a function, this becomes the body of my function. So I get function, I don't know, M flipped. In order to do this, we'll call it FlipMatrix, I need M. That's it. And then end. So that's what my function looks like. So here we go. So I've got my function. I'm adding some comments in here to identify the use case, the inputs, outputs, what it does, and here's my one line of code. So if I want to call that function, I can go ahead and I can say, if M looks like that, then M flipped equals FlipMatrix M. And there we go. Here's my original matrix, and here it is flipped upside down. But key thing, what do we want to store? Where do we want to store something? What do we want to store there? Which rows, which columns? And I don't even need these brackets. So notice there's no brackets in there. It's just M, these rows in this order, and these columns. Okay, next one. Next one, write a function that exchanges the last 2 columns between 2 matrices. So now I have 2 matrices. So I'll do A, random between 1 and 5. We'll make it 2 rows, 4 columns. And B, randi 1 to 5. We'll make it through 2 rows, 3 columns. So note, They need to have the same number of rows, otherwise I cannot exchange their last columns. Okay, so A looks like this. Once again, it doesn't matter the numbers because I'm exchanging the last two columns. And then B looks like this. So I want this column and this column to switch places. So it just becomes basic swap. It just becomes basic swapping. So essentially, what I need to do is I need to create a temporary variable that's going to store my last column of B. So last column of B. Then I'm going to put A, my last column, and store it as B, temp. Actually, no. I'm going to take B. Let's do it in the right order. Make the last column of B the last column of A. And then I can say A, last column, equals temp. This is one of the ways to do it, where we just create a temporary variable that stores one of our pieces that we're swapping. So I'll say temp equals B. How do I indicate the last column? I want all the rows in the last column. And now I can say A, or B, my last column, which would be B, end, equals my last column of A. So put that piece in there. So here's what it looks like. So temp stores this. Temp stores that. And then I go ahead and move this piece into here. And then I'm going to go ahead and move this piece into here. That's what I'm doing. So you notice my illustration over there on the side. So then last piece, A, last column, equals temp. That's how it works. Okay, so if I illustrate it over here one more time, we'll make a blue and make B green. I need to go ahead and create a temporary variable where I'm going to say my last column of B goes in my temporary variable. Then I'm going to move my last column of A into B and then move this into A. That's one of the ways to do it. That's one of the ways. We could also construct it differently. We could say that a new equals a new matrix where it's the first 1 to n minus 1 row. Nope, all the rows. Which columns? 1 to n minus 1. So the first this many rows, or this many columns of A. This would be all the rows 1 to n minus 2. And then place that next to the last column in B. So that's another way to do it. And then say B new, same idea, where we say B, all the rows in the first n minus 2 or minus 1 columns. That should be a 1. Place next to A, and both of these will work. Both of these will work. So if we look at it, if we run our code, so let's clear this. If A and B look like this, so this is what happens at the end of that. We can see A, the last column in A is now inside of B, and the last column in B is now inside of A. Or we can look at it this way, where we construct two new matrices, that takes the first part of A and the last part of B, puts them together, and the first part of B and the last part of A and puts them together. Okay. So that becomes how we can do that. Notice there's multiple ways to do it. What do we want to change? What are we modifying? Where are we storing something? What are we putting there? Okay. So if we want to go ahead and put that into a function, this would be our function. Our outputs would be A and B, and I don't know, swap. Our inputs would be A and B. So notice it's kind of wonky here, where A and B are both our inputs and outputs. It really depends on how you want to write your functions, but it's not invalid. And there we go. Or we can have a function here. This could also be it, where you have A new and B new. My inputs would be A and B still here, and then I'd end here. Okay. Both of these functions will do the same thing. So notice now we're getting to the point where things can happen more than one way. Okay, so here I have SwapLastColumn. Here's my two methods, method 1, method 2. Either one works. Notice this one, I created two new matrices. I started it out with being equal to A and started out with being equal to B. So it's another way to do it. Add in some comments. If I want to use that function, then I go ahead and say, okay, I need a modified, two output variables equals SwapLastColumn, and then I need two inputs, A and B, and there we go. So here's my two matrices that have been swapped. Okay, another one.
So there's those first three matrices. Now, they all have the same number of columns, right? So you can stack them.
Write a function that interleaves two arrays of different lengths where the extra elements are appended to the interleave array. So it says arrays. We'll change this to vectors, just because it'll make our life a little bit easier. So vector 1, random numbers. No, we'll call it ones. We'll just fill it with ones. Ones, one row and 6 values. And then vec 2, we'll call it zeros, one row, and we'll say 4 values. So here's my two vectors. I want to interleave them, where it ends up being 1. Honestly, it doesn't matter which one we start with, but it'll be 1, 0, 1, 0, 1, 0, 1, 0, as many as we have, and then whatever's left over would be the remaining elements from a different vector. So these ones here come from vector 1, and these zeros here come from vector 2. Okay, so this one requires a little bit more thinking. There's a lot, well, I guess a lot more thinking. There's a little bit more involved with this problem. It is relatively challenging. So one of the first things I need to know is I need to know which vector is smaller, because this part is just inserting the even values and the odd values. Right? It's whatever's left over here that's hard. So first I need to go ahead and figure out which one is shorter. In order to do that, I need to know the length of my vectors. So I need to know how long vector 1 is. So we'll say n of 1 is the length of vec 1. Okay, number of elements in vector 1. And then n2 we'll say is the length of vec 2, or the number of elements in vec 2. Okay, and then I need to figure out which one is smaller. To do that, I can use the min function. So n of smallest would be the min of n1, n2. We didn't go over this function, but it is something I can use. There's other ways to figure out the minimum, but I can just use the min function in MATLAB, which if we go ahead and open on min, it gives me all this documentation. We can also right-click and say help on min, and it'll pop up a dialog box somewhere. There it is. And we can see how to use min, which this is one of the ways to use min. So min, n1, n2. So if I highlight over this and run my code, I can see the first vector is 6 elements, second one is 4 elements, and the smallest one is 4. Okay, so now I just need to interleave. Interleave the first small, or I guess n times 2 values, where n is my smallest length. So I take the first, so vector 1, elements 1 through n, and vector 2, 1 through n. I'm going to insert these in the odd locations, insert these in the even locations. So my final vector, or I guess I'll call it interleaved, is going to be zeros, one row, and it's going to have n1 plus n2 elements, right? That makes sense. That's how big it's going to be. I'm going to fill in all of these spaces. So the odd locations, interleaved, 1 through, through n smallest, times 2. These are the odd locations, are going to be equal to vec 1, 1 through n smallest. Okay, you see that? These are the odd locations. Let me make this vector 1 through, nah. These are the odd locations. So starting with location 1, and then 3, and then 5, and then 7, etc., all the way until smallest times 2. So all the way until 4 times 2, all the way until the 8th location. So with my interleave vector is this many values. I want to go ahead and replace this one, this one, this one, and this one. Because this, nope. This, no. I can do this. Oh my gosh. 6, 4, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, these ones. I think I have 1 extra. I do. I drew 1 extra 0. These ones are going to be filled by interleaving. These ones will be filled by the first values in vec1 and the first values in vec2, all the way up until 4. Okay, so we started out by being all zeros. And then we go ahead and fill the even locations with the first 4 values in vec1. I'm going to change vec2 to 2s, just because it'll make our lives easier to see. So vec2 is now filled with 2s. Okay. So here we go. So now I need to fill in the even locations, interleaved of 2 to n smallest times 2 equals vec2, 1 to n smallest. Okay, remember, I don't know which one is the smallest, so I need to do 1 to smallest on both of them, because I don't know which one has the smallest length. Okay, so now here's my even location, starting at 2, then 4, then 6, then 8, all the way until 8. There we go. So now these ones are interleaved. Now I just need to replace these last 2. Where I can replace the last 2, interleaved, of 2, n smallest, times 2 plus 1. So this location here, all the way until the end, I'm going to fill it with the values in vec1 of n smallest plus 1 to the end. So all my remaining values in vec1 next to all of my remaining values in vec2. And this is weird because there are no remaining values in vec2, but it just fills it with empty. So here's the values from vec1, and the values from vec2 are just empty, so it doesn't insert anything. Because these ones don't exist, so it just says nothing. So now if I do this, there we go. Now these ones are replaced. So there's a lot going on here. So let's review it. First, I have vec1 and vec2. I've got these 2 vectors. I'm going to interleave them. I determine the number of elements in vec1, determine the number of elements in vec2, figure out which one is smallest. Then I create a vector that's as big as it's going to be. It's going to be as big as vec1 plus vec2, the number of elements. And then I take all of my odd locations and fill them with vec1. At least 1 to smallest. At least the ones that overlap. 1, 2, 3, 4, 5, 6. These ones. I'm going to interleave these ones. So this here is location 1 all the way to the smallest value. And location 1 all the way to the smallest. So vec1, those values go in the odd locations. Vec2, those values go in the even locations. And then all of these elements, so smallest plus 1 to the end, and then same thing here, these ones get added at the end. So if I change it now to 4, we'll change it to 5 and 7, and run my code, I can see now it's the same thing. So vec1 is now shorter. So the 1s go in the odd locations all the way until the smallest one. The 2s go in the even locations, and then whatever's left over gets appended on. So once again, we go back to where do we want to store something? What rows do we want to change? What elements do we want to change? And what do we want to put there? So there's a lot going on in this example here. So if you can follow it, that's great. It helps to have a written piece of paper to figure out what's going on, how our variables are changing, how our values are changing. So this goes in my function. My output would be interleaved equals function, whatever you want to call it. And in order to do this, I need my vec1 and vec2. One other thing to note is I don't have any hard-coded values in here. I didn't say, oh, the smallest length is 5 between the two. I needed to write code in order to figure that out for me, because it's not always guaranteed to be 5. These vectors can change different lengths. They can be different sizes. So I need to figure out a way to write code to tell me, to ask my values themselves, how to get the smallest value. Same thing here. I'm not going to manually interleave. I need to figure out, okay, how do I insert the even numbers from this vector? How do I modify the odd values from this vector? Okay, and that's what makes this material challenging, is figuring out how to make it work for any set of vectors, any generic set. Okay, so there's our function. Here's what it looks like in here. I called my variables different, but it's the same idea. Same idea. I did this one a little bit different. I didn't initialize my output vector with zeros. Instead, I made this vector first, and then I just said out is placed next to the last values in vector 1, next to the last values in vector 2. Okay, so if I want to use that function, we'll change this again. We'll make this 4 values, and we'll make this 8 values, or 9 values. So now I want to go ahead and say interleaved equals interleave, that's capital, interleave vec1, vec2. Oh, no, capital interleave. There we go. There we go. So here's vec1, here's vec2, and we can see that didn't work. Why didn't it work? Did I? Oh, I did vec1, and there we go. There we go. Type things incorrectly. Vec1, vec2. So here's vec1, here's vec2. I can see the first 8 things are interleaved, and then whatever's left over is added on. Okay, last example. Last example, write a function that deletes a given row and column from a matrix and stores the deleted elements in a single column. So I need a matrix. Rand I 5, we'll say 5 rows, 8 columns. So there you go. And I want to delete row 4. Delete me. And I want to delete column 3. Okay, so note, in order to do this, I need to know which row and column to delete. Okay? And I create variables for them. Because if I have everything stored in variables, then I can just use the variable instead of using the value. So here's my matrix. Once again, doesn't really matter what the values are. There we go, 8 columns. So I want to go ahead and delete row 4. So I want to delete this row. Let me use this. I want to delete this row. And I want to put my deleted elements in a separate vector, in a separate column, single column array. So this would be a column vector. Okay, so first thing I'm going to do is I'm going to take those values. Deleted elements. I'm going to take these values, copy these values, and put them in this vector. Then I'm going to go ahead and delete them. And then let's say I want to delete column 3. Then same thing. I'm going to take these elements, copy them into here, and then delete it. Okay, so first thing, my deleted elements. Equals m, which row, which column am I guess it doesn't matter which one I start with. We'll say rows, row 4, all the columns. And note, that's a row. I want to go ahead and transpose it. I can't really move it. But I would transpose it,
Column 6, column 12,
delete, transpose it,
column M1,
make it a column
row M1. This is
with my
M1
transpose.
plus 1 to M1 plus
Okay, so store
Then we start
row values
plus 3 plus 1.
in vector, in column vector. So that's why I need to transpose it. So then I can go ahead and delete that. So I can say M, which row? I'm deleting this row,
See how it works.
equals empty.
We coded it. Right? Because we used
So M started out being like this, and I deleted row 3. If I look at deleted elements, no, it's all the values. It's not. Am I doing the right row? 2, 2, 3, 3. Row. If you ever need to debug, just execute your code one at a time. Yeah, this one works. This one works. Oh, I know what I did. I re-executed code. My bad. Run your code one at a time. So do this, then do this, then do this. Okay, I re-executed this after M changed. Okay, but there we go. So we started out with M like this. We took this row, stored it in our deleted elements, and then we deleted it from M. And I would just do the same thing. So deleted elements equals. Now the only difference is I don't want to remove the elements I already have in this variable. I just want to append them. So I'm going to say put the elements from deleted elements next to, or I guess on top of, the column that I'm deleting.
All right, good luck.
So now I'm going to delete column 3. So I took the elements I deleted before, and I placed them on top of the elements from column 3. Then I can delete my column. The order matters. The order matters. I need to take my deleted elements first, store them in a vector, and then delete my row. Then take my new deleted elements, put them on top of or on the bottom of my already full vector, and then delete that. So once again, this would go in my function. It returns 2 things. It's going to return M and deleted elements. In order to do that, it needs a matrix, and it needs a row and a column to delete. And then we'd end. Here was what it looks like. I add in some comments. The only thing that's different here is rather than saying my matrix is my output, I create a new variable that stores my output or my modified matrix. Okay, but here's the same thing. Store my elements in my output matrix, delete them, add my elements to my elements matrix, and delete them. So if I want to call that function, I can say AB equals delete row column MRC, and we can see how it works. So no, it's not a column vector. In there I made it a row vector. But here's my matrix. Row 4 is removed and column 3 is removed. And here's all the elements, or all the values that were removed. Okay, so that's 4 more examples. Hopefully that helps in terms of figuring out things in a generic form. What I recommend is store everything in a variable. Anything that might change, store it in a variable. Use that variable anywhere you can.